All right, Math 9 semester class. This is Mr. McPhee here. Today, it's April 7th for me. I don't know when you're watching this video yourself. Hope you're having a good day. I'm going a little stir crazy here, so are you ready to go with Math 9? Here we go. Alrighty. So today we're going to look at multiplying and dividing monomials, which is always good times. When you got nothing to do in the world, this is the best thing you can do to keep yourself out of trouble. Here we go. So remember, a monomial is just one term, no add or subtract. You've done adding and subtracting, which I'll kind of allude to today. So here, again, when you look at this looks stressful when at first glance, like anything in math. So just let me hide this so it doesn't look really bad. You've done add, subtract, which is collecting like terms. Today we're going to talk about multiplying and dividing. So what I've done to kind of show you the connection, I've taken 10x, 10x, and 10x. Here I'm doing adding 2x. Here I'm multiplying. Remember, when two numbers hug, there's a multiply in here by 2x, and here I'm dividing. So really it's the same two monomials, just here I'm adding, here I'm multiplying, here I'm dividing. And for each one of those, there's very different rules for each one. So for the add subtract, which is what you know, remember, for add subtract, you have to do like terms. There's no other way. So adding and subtracting is like terms only. Are these like terms? Yes, they are, because they have the same variable and same exponent. So the rule literally is you just add the coefficients. So 10x's plus 2x's is 12x's. Done. So that's review. When you're multiplying, though, you don't have to have like terms. You literally multiply the coefficients and you multiply the variables. So if I reorder this just means 10 times x times 2 times x. So I'm just going to write it out. This is all it means. And if I reorder multiplication, for example, if I had 2 times 3 times 5, that's the same thing as 2 times 5 times 3. So I can just reorder this. This just means 10 times 2 times x times x. I've just reordered it. Notice I can never, ever, ever do this with add subtract. I can only do this when I'm multiplying monomials together. And then you just literally go, okay, I can multiply the two numbers. That's 20. And x times x, you're allowed to multiply variables. That's just, remember your exponent rules, that's just x squared. So two things to notice. One is add, subtract, like terms only. The exponent never, ever, ever changes. When you're multiplying, because you're allowed to multiply different variables together, the exponent can change. Multiply coefficients and multiply variables. When you're dividing, same rule. You're allowed to divide monomial by monomial. You divide the numbers just like you would a regular fraction. So 10 divided by 2 is 5 over 1. So this will turn into 5 over 1 in lowest terms, or just 5. And then x divided by x, they divide right out. So you're allowed to divide those two out just like you would with exponents. And you're left with 5. So notice how those are all very different, and yet they all got an interesting connection with them. Let's look at another example to let this kind of sink in. So here's the next example, which again, I've done 3 of similar things. An add subtract question of monomial minus a monomial. Here's the same 2 monomials but multiplied. Remember, there's a multiply in here. And here is a divide. So let's look at this one first. The add subtract one that you know, like terms. Are these like terms? No, because this is an x squared y term, this is a y term. If someone said to add and subtract that, you should look at them and go, I can't. This is done. These are unlike, over. Like, that's almost the best question in the world, and yet the hardest question. The next one is multiplying. So when you multiply, you are allowed to reorder this. So I can put the 12 times the negative 10 together. And I could put the x squared and the y. So all I've done is reordered it. This multiplied this. I can multiply the coefficients and I can multiply the x squared, the y, and the y. So you end up with 120 negative, because a negative times a positive is a negative, and 12 times 10 is 120. X squared doesn't have anything other x's to multiply by, so it just becomes x squared. And then y times y is y squared, because I am allowed to multiply those together. There's my answer. When you're doing dividing, again, just look at the coefficients to start with. What's 12 over negative 10 in lowest terms? What goes into both? I can see a 2 going into both. So divide by 2, divide by 2. 12 divided by 2 is 6. Negative 10 divided by 2 is negative 5. The x squared, if you look at it, it has no x's on the bottom, so there's nothing to divide out. It'll just stay in x squared. There's no other x's on the bottom to cancel with. The y's, though, divide out. Goodbye to you, little y, and there's my answer. So hopefully that makes sense. The next two examples are more of a dealing with perimeter and area, because they might give you shapes as a connection piece. So when they give you a rectangle and they want perimeter, remember perimeter is the distance around. So I'm going to be adding here, if I go around, it's going to be 3x plus 6x plus 3x plus 6x. So 3x plus 6x plus 3x plus 6x. And because it's adding, I can add like terms. What's 3x's plus 6x's plus 3x's plus 6x's? They're all like terms. So I got 9 plus another 9. This is 18x. There's my perimeter. Area, remember, of a rectangle is the amount of space inside it. So that's always length times width. So length times width. In this case, 6x is my length. I always think of the length as a longer one. And 3x is my width. Now be careful here, this time symbol is not the same as this x. So I replaced that time symbol with a dot. And now it's like, oh man, what's my rules for this? Oh yeah, I multiply coefficients, because multiplying I can multiply that. That's 18, 6 times 3, and x times x, x squared. There's my area. Completely different process. This is not collecting like terms. One other type of question they might throw at you might be something like this, where they give you one side of a rectangle and then the area, and then you have to kind of muster up the knowledge of what must this side have been, so when you multiply these together you get this. But if you think about it, remember area, when you have the two sides, is multiplying. When you're going backwards, you're going to divide. So to find out the missing side, you'll take the area, which is this, and you'll divide it by the one side that you know. And so you can see here, well, 24 divided by 2 is 12, which makes sense because 2 times 12 would give you the 24. Here the x's divide out completely, so no x's. And then this y is a power of 1. It will divide into one of these. One y on the bottom will divide out to 2 y's on top, and you end up with 12y. Now just look at that for a minute. Does that make sense? If you multiply these together, would you get 24xy squared? 24, there's an x, and y times y is y squared. So there, that's the answer. Last little bit, and then we're done, because I don't want to hold you up too long. Should be about 10-12 minutes or so. The only thing I can see them doing that can be kind of sneaky would be they might throw some weird fractions at you, and they might throw some things that are almost so easy they're hard. So again, look at these multiplying ones. Multiply, multiply. Multiplying, multiply the coefficients. 7 times negative 6, negative 42. A times B is almost so easy it's hard. People are like, how do I multiply that? Well, it's just AB. That's it. That is almost so easy it's hard. People mess that up even though it's just a simple, oh, it's just AB. When you get a question like this, you look at it and go, oh man, these are just ugly fractions. But what's the rule? Well, you need to multiply these two coefficients. What's the rule for multiplying? What's 2/3 times 4/7? The rule for multiplying fractions, remember, is numerator times numerator. 4 times 2, 8. Denominator times denominator. 3 times 7, 21. So there's those done. And now what's x times x? Well, I could write xx, but that's preferred to be right as x squared. Done. Don't let those ones bully you around. You bully them back. And then the only thing I think about for divide, these are just little twists that might throw you off. Really, there's no differences here. When you divide coefficients. 8 divided by 2 is 4. X cubed divided by x. This x will divide out one of these x's, and because there's 3 here, x, you'll end up with 2. So it'll be 4x squared. Really, your exponent rules come back to help you there. For this question, negative 18 divided by 2, negative 9. P's divide out completely because they're both the same power. Q's divide out, and you're just left with negative 9. That almost bugs people because they're like, well, where's my variables? Well, they divided out by total fluke. And the last one, if they use the old division symbol from your elementary days, you could either leave it like that, or you could write it like this. And this again bugs people because they're like, man, I'm supposed to divide coefficients. What's the imaginary coefficient here? There's an imaginary 1. What's 0.6 divided by 1? Well, that's pretty easy. That's 0.6. And then what's x squared divided by x squared? It'll divide completely out because they're both the same, and you're just left with 0.6. Alright, so I'll post the homework and this video onto the website, and I hope you have a good day, and hopefully we talk sooner than later. Have a good day. Over and out.